Hey, this is Mr. Beckstrom, and today we're going to be looking at a problem in section 2.2. This deals with functions, how we define them, finding domains and intercepts, and lots of good stuff about functions. So the first thing that I want to do when I get a function problem like this is I usually like to put it into my calculator, which I've already done. I'm going to put it in just like this. I put both the numerator and the denominator in parentheses. And then I like to zoom standard, and I can kind of get an idea of what this graph looks like. I can zoom out, zoom in, but it looks like it crosses the x-axis somewhere around -4. Looks like it crosses the y-axis somewhere around -2/3. It's somewhere between 0 and -1. And this just kind of gives me an idea of the behavior of this curve here. I also might have a vertical asymptote somewhere around x is equal to 5. So looking at that, let's try to answer these questions here. So the first one is the point 3, -2 on the graph of f? So if I actually go back up to my calculator, I can say, well, if I put in, or if I go to 3 here, and I go down, it looks like that point is actually a little bit closer to -3. So I'm going to really have to evaluate it to find out. Now I can use my calculator to do that, and I'm going to show you how we can do that again. So if you go out here, and we already put in our y1, so I hit vars, I go over to y variables, I do my y1, so I'm going to say pull up that y1 function I just put in there and evaluate it at 3. Evaluate it at 3, because that's my x value. Enter, and I get -3, not -2. So this point is not actually even on our graph. And I can actually do this by hand if I wanted to as well, just by replacing the x with a 3, and you'll get 6 over -2, which indeed is -3. So this is going to be a resounding no, although it's close. The second thing is, it says if x is equal to 2, what is f of x? Well, once again, I'm going to go to my calculator, and I'm going to say, well, I'm going to replace x with 2, and my f of x is, and I'm going to hit math, fraction, convert that to a fraction, -5/3. Now, I'm actually going to do this one by hand, just so we can see it as well. So, b, all right. All I'm going to do is say, let's evaluate the function at the x value of 2. And that means I just go in and replace all of my x's with 2. So this is 2 plus 3 all over 2 minus 5. And this is equal to 5 over -3, which indeed is just -5/3. You can pull the minus out front. Alright, so -5 over 3. Alright, now the next thing says, what is the domain of f? And we actually looked at a problem in section 2.1 like this, so if you want to go back and review that, you can, but generally speaking, we start with kind of the assumption that it's all real numbers, and then we see if there's any restrictions based off of the function. And it looks like there is. Remember, whenever we have a 0 in the denominator, our function is undefined. So we want to figure out what values those are and restrict them from our domain, take them out. So if I just, if I just let my denominator equal to 0, because that'll tell me any x, x minus 5, so this is my denominator, set it equal to 0, and we'll quickly see if we add 5 to both sides that x is equal to 5. So if I put a 5 in this function, sure enough, 5 minus 5 is 0. I'm going to have a 0 in the denominator, and it's going to be undefined. And we actually saw, looking at our graph, let me go back to our graph, that, yeah, at this vertical line here, it doesn't look like there's any solutions. It's actually a vertical asymptote, which we will be talking a lot more about in this semester. But this means that it's our domain is going to consist of all real numbers except for 5. So if I put that in interval notation, it's going to look like this. We start with negative infinity, and we always put a parentheses because we don't technically include positive or negative infinity. And we're going to go all the way to 5, so it includes all of those x values, so everything up from negative infinity to 5, but it does not include 5, so we put a parentheses, and then we're going to start at 5 again and go all the way to positive infinity and put a parentheses. So this is interval notation, and this is basically saying it's all real numbers except for 5. All right, and D. If f of x is equal to negative 4, what is x? So this is kind of like a reverse problem of B here. What we're doing is we're replacing this f of x here with a negative 4, and we're keeping the right the same. So x plus 3 over x minus 5. And then in this case, I'm going to solve for x. So the first thing I'm going to do is I'm going to multiply both sides by x minus 5. And that'll get rid of this denominator on the right. So if I multiply both sides by x minus 5, on the left I'm going to have negative 4 times x minus 5. And on the right, I'm just going to have the x plus 3 because the x minus 5s will cancel out. X, let me get that a little bit better. X plus 3. And then I'm just going to solve from there. So let's kind of start back up here at the top. I'm going to have negative 4x plus 20. I'm just distributing that negative 4 plus 20 is equal to x plus 3. And I can add 4x to both sides, so I'll get 20 is equal to 5x plus 3. I can subtract 3 from both sides now, so that's going to be 17 is equal to 5x. And finally, divide both sides by 5 and flip it around. X is equal to 17 over 5. Which is equal to, what is that, 3.4? 3.4. So if I go back to my calculator, and let's do this here. I've got my calculator open. Got it there, and I'm going to check my answer here. So I'm going to pull up the y function. I'm going to say evaluated it at this x, 3.4. And I should, if I did it right, get a y value of negative 4, which is correct. All right, now the next one says list the x-intercepts of f, and once again, if we look at our graph, and I just want to go ahead and zoom out a little bit. Zoom out. Let's center around here. It's kind of hard for me to tell, but it looks like it's only crossing maybe in this one area here. So I'm expecting to just get one x-intercept. And to get the x-intercepts, what I do is I let my y equal 0. So when I'm trying to find my x-intercepts, I'm going to let my y equal 0. So that means I replace y, which is f of x, with 0. And that's equal to x plus 3. Over x minus 5. Now I can go through and multiply both sides by x minus 5, which will just keep the 0 on there. And I should just get the solution that x is equal to negative 3. Remember, the only way this fraction is going to be equal to 0 is when we have a 0 on top and a non-zero on the bottom. Because if you have a 0 on the bottom, the function is undefined. So the only way for this whole fraction here to be 0 is if we just have a 0 on top. So really I can just look at the top of this. So x is equal to, and we see negative 3 is our solution there. And I can actually go and check it again in my calculator. Let's do that. So I'm going to go back to my vars and evaluate this at negative 3. And we should get a 0 back, which we do. Put an extra parenthesis in, but it worked. All right, so that's my x-intercept. My x-intercept here is negative 3, 0. And my y-intercept, it's very similar to the last one. For the y-intercept, we're just going to let our x equal 0. So this is f. So what I'm going to do is I'm just going to say y is equal to, remember I can either say y or f of x, they're the same thing. Y is equal to, and I'm just going to replace x with a 0, so that's 0 plus 3 over 0 minus 5. 0 minus 5. And that's going to give me that thing that I got earlier, right? Negative 3/5. So that will be my y-intercept. So I can write that as, remember, it's going to be 0, negative 3 over 5. All right, that's it. If y'all have any questions, let me know, and I hope you have a good rest of your week.